Currently, glaciers are the largest reserves of freshwater on Earth, holding an astonishing 75% of our planet's fresh supply. These icy giants cover about 10% of the Earth's surface, a significant decrease from the 32% coverage during the last ice age. There are two main types of glaciers: alpine glaciers, which carve their way down mountainsides, and the massive continental glaciers, such as the Lambert Glacier in Antarctica, the largest existing glacier, measuring about 100 kilometers wide, 400 kilometers long, and 2.5 kilometers deep. But what if this immense icy mass were to disappear suddenly? Before we get started, please make sure to like the video and subscribe to our channel if you haven't done so yet. Number 1. What would happen? The ice covering our planet is immense, estimated to be between 25 and 30 million cubic kilometers. To grasp this enormity, imagine if all this ice were spread out in a layer 1 kilometer thick. It would cover an area larger than North America. But what if this colossal ice mass melted overnight? The implications are staggering. According to the Intergovernmental Panel on Climate Change's 2019 report on the ocean and cryosphere, the impact of melting glaciers is alarmingly significant. This report highlighted that smaller glaciers alone could contribute nearly as much to sea level rise as Greenland's ice sheet. To give a sense of scale, Greenland lost approximately 280 billion tons of ice annually between 2013 and 2015, while other glaciers lost about 220 billion tons during the same period. In contrast, Antarctica shed 155 billion tons of ice. The rate of ocean surface rise in recent years has averaged 3.6 millimeters per year. While this might seem small, it's important to remember that climate changes accumulate over time and can suddenly accelerate. NASA has predicted an inevitable sea level rise of around 90 centimeters shortly. But the situation becomes even more extreme in our hypothetical scenario, where all glaciers melt overnight. Currently, glaciers and ice caps cover about 10% of the world's land mass, predominantly in regions like Greenland and Antarctica. If these ice-covered areas were to melt, significant portions of land currently under ice could potentially become exposed. For example, Greenland's ice cap, which is up to 2 miles thick in some places, exerts so much weight that parts of the land have been compressed below sea level. If this ice were to melt, it could reveal new landscapes, although some areas might remain below sea level due to the land depression caused by the weight of the ice. Scientists from the University of California, Irvine, have made projections for such a scenario. If Greenland's ice were to melt entirely, sea levels would rise by about 7.4 meters. The complete melting of Antarctica's ice would result in a 58-meter rise in sea levels. And if every glacier on Earth melted, we're looking at a rise of around 70 meters, about 230 feet, profoundly transforming the world's geography. This dramatic increase in sea level would affect every coastal city on the planet, leading to significant loss of land, especially in low-lying coastal areas. Coastal cities and low-lying areas across the globe would be flooded. Places like New York, Mumbai, and Amsterdam would face severe flooding, displacing millions of people and causing unprecedented economic and social upheaval. The new coastlines formed would be unrecognizable from today's maps. Number 2. What part of the land would remain? However, not all land would be lost to the sea. Higher elevation areas would remain above water. Cities located at higher altitudes, like Denver, would survive this massive sea level rise. In fact, any region sitting above the new sea level of 70 meters would remain as land. This rise in sea level would create new coastlines and potentially new inland seas, especially in areas with low-lying topography. For example, predominantly desert Australia could gain a new inland sea, although it would lose much of its narrow coastal strip where most of its population currently resides. The Antarctic ice cap contains the majority of Earth's ice, more than 99% of the land ice on Earth, and holds over 68% of the Earth's fresh water. The Antarctic ice sheet spans almost 14 million square kilometers, about the size of the contiguous United States and Mexico combined, and is up to 4.9 kilometers thick at its thickest point. It has survived much warmer times in the past. While portions of the Greenland and West Antarctic ice caps are at risk of melting, the Antarctic ice cap is less likely to completely disappear. Number 3. Drastic climatic repercussions. One of the major climatic impacts is the slowing down of ocean currents due to glacial thawing at the poles. This phenomenon is intricately linked to changes in the global climate and the occurrence of increasingly extreme weather events worldwide. The melting of glaciers is not just a matter of water levels rising, it affects the entire climate system. For instance, as glaciers recede, they expose dark ocean water or land, which absorbs more sunlight and further accelerates warming, a process known as the albedo effect. This warming then impacts weather patterns and can lead to more frequent and severe storms, droughts, and heat waves. It's a chain reaction that affects the whole planet. One key aspect to consider is the effect of fresh water from melting glaciers on ocean salinity. Glaciers, being made of fresh water, can decrease the salinity of the ocean water when they melt. This change in salinity can affect the thermohaline circulation, commonly known as the ocean conveyor belt. This circulation is driven by differences in water density, which is influenced by temperature and salinity. When glaciers melt, the influx of fresh water can disrupt this balance, potentially slowing down these currents. For example, in the North Atlantic, the melting of Arctic sea ice and Greenland glaciers could significantly alter the pattern of ocean currents. Freshwater influx from melting ice dilutes the seawater, making it less dense and potentially disrupting the normal sinking of cold, salty water. This process is crucial for driving the Atlantic Meridional Overturning Circulation, AMOC, a major component of the Earth's climate system. A slowdown in the AMOC can have widespread climatic effects, including changes in weather patterns, sea level rise, and a decrease in marine productivity. Climate models and observational studies often provide projections and trends as the system is influenced by a multitude of interconnected factors, including atmospheric conditions, oceanic currents, and global temperature changes. Number 4. What will happen to Antarctica? Currently, Antarctic sea ice reaches a size equal to the continent itself at its peak. Since satellite tracking began around 1980, Antarctic sea ice has experienced significant reductions in its extent. The most notable decrease occurred in recent years, with a record-breaking low in sea ice extent. Specifically, in 1 year, the sea ice was nearly 350,000 square miles smaller than the smallest amount previously recorded in 1986. This represents a substantial decrease, indicating a trend of shrinking Antarctic sea ice over the past few decades. The loss of sea ice exposes more ocean water to heat, which in turn makes it harder for ice to reform. The National Snow and Ice Data Center highlights this new regime where warm ocean waters have a stronger influence, limiting ice growth. The West Antarctic ice shelf, a particular area of concern, is melting rapidly due to climate change. This ice shelf alone contains enough water to raise global sea levels by about 10 feet. Scientists fear that once the melting in West Antarctica gains momentum, it could lead to an unstoppable disintegration. If all the glaciers in Antarctica were to melt, the global sea level would rise by about 58 meters. This event would drastically change the Earth's geography, submerging many coastal cities and reshaping continents. The melting ice would shift the Earth's weight distribution, potentially lengthening days by up to 20 seconds. Antarctica's diverse wildlife, including penguins, seals, and whales, would face devastating impacts as their ice-dependent habitats disappear. The melting would also release ancient, durable microbes, possibly including unknown diseases, into the environment. Number 5. Positive effect of glacier melting. While there are some known positive outcomes of the melting of all glaciers, it's crucial to acknowledge that these do not compensate for the vast negative impacts such a scenario would cause. The drastic rise in sea levels, loss of habitats, and massive ecological disruptions are just a few of the detrimental effects that far outweigh the benefits. However, focusing on the brighter side, one area where positive changes could be observed is in international shipping, particularly in the Arctic. As the Arctic ice melts, new maritime trade routes are expected to open in international waters. These routes could be shorter and more eco-friendly compared to traditional ones like the Suez Canal and Panama Canal routes. A study by Brown University projected that by 2065, the Arctic's navigability would increase substantially, offering new trade routes that bypass the Russian-controlled Northern Sea route. The potential new Arctic routes are particularly significant because they are 30% to 50% shorter than the current major routes, potentially reducing transit time by an estimated 14 to 20 days. This shorter travel distance could result in the shipping industry reducing its greenhouse gas emissions by about 24%. The opening of these routes not only presents an opportunity for economic and environmental efficiency, but also offers a diversification of trade routes, adding resiliency to the global shipping infrastructure. There you have it, the big melt. It's a mysterious unknown scenario that's as terrifying as it is fascinating, and it underscores the need to protect our planet's glaciers. If you enjoyed this deep dive into a world without glaciers, make sure to like and subscribe.